make it more like a discussion, is about the value of data. How you actually benefit of this, what you can do with data, and most important, because we are geeks, and how we actually can deal with the design system that the shifter allows you to use data. So I'm a software engineer at Pivotal. I'm helping in my day jobs customers on their to become data-driven company journeys, and I'm privileged to be allowed to spend a significant amount of my time on open source projects. I'm a project committer and contributing to some other projects. Within Pivotal, I'm focusing on the data aspects, big data, analytics, and that would be the focus of the talk today. Hopefully, I mean, I really believe in connecting dots. I already can connect dots with various use cases I've heard so far. Hopefully, after my talk, you will also see some interesting intersection point that actually you can leverage, and I would love to discuss it later on. So, what is data? What is the value of data? I mean, there's a lot of research out there trying to assess how you actually can value the data sets that you use and how that reflects with your business cases, but this is not what we're about to talk today. So it's very important aspects, but it is just a driving force that you have to consider. What is more fascinating and what I'm interested in is how the different data sets can connected together can help you review stuff or know facts that you don't know initially. So this is very fascinating aspects of processing data nowadays, and it's really related to the analytics and the way how you do actually predictive analytics and machine learning, how you combine algorithms, and this actually is one level how to automate automations. And when you start designing and thinking about such type of data system that process, traditionally you have two different type of data system that process data. One historically called transactional system, and Mifos, to the best of my understanding, falls into this system. Usually those type of systems process large amount of data, usually with a small payload, but in concurrency with high speed. And high speed is very, real time is a critical aspect of those systems, transactionality as well. And on the opposite side, you have another class of system called analytical system or lab system, where actually operate a very large amount of data. Very often, nowadays, this is related with big data, with very complicated queries. So, as an opposite of the transactional system, where actually the type of processing are very simplified as a complexity of the operation that you do on data. But this is the world, and traditionally there is this kind of trend trying how can we actually get the best of both worlds, transactional analytical data. So we really want to be able to perform very complicated queries across all our data sets, and we still want to have the insights about the outcome and be able to ask those questions and query this data in real time. So if you go down to a single statement, what data system is supposed to do is really to allow you to compute any answer or give any answer using all your data that you have, no matter what is the amount of the data, what is the speed this data gets ingested, or how different is the shape of the format of the data. So it's practically you want to have a query that is function of all your data. And in order to design such type of system, various principles have evolved. For example, data very often is interchangeably related with the term information, but data itself, you can have a different type of data. You can have a raw data and you can have derived data. So when you design the data system, it turns out that being able to preserve the fact data, the original data, is a critical element of designing such system. You always can actually reproduce the derivative data formats afterwards, but in order to reproduce those or derived data sets, you have to have another property with design, another property with your system. This is the determinism of the functions that actually compute your next data set. Having this in place allows you to do yet another nice feature, which is the data lineage. So practically, for each data set, you can actually go backwards and say from the original how it has been created, and actually, most importantly, you can recreate it later on in case of human or machine failure. You can use it for parallelism. There's different benefits, but I'm just building the context around how you build the system and what is the driving force behind. I'm not going to list or explain the principles in detail, but just wanted to give you some insight and hints about what are the driving forces. Some are technical, some are business, some are really pragmatic decisions that are driving the systems. So I already mentioned a couple of those principles. Another way to look at designing the systems is, and there is emerging patterns that actually go out there to how we can build systems and integrate it. As I said, there is a drive to try to merge the operational or transactional type of systems with analytical type of systems so that you can answer the questions, compute all your data using all your data, or computing all answers you can have using all your data. So data lake is one typical architectural pattern that is used nowadays. Actually, it advocates that you should collect all hard data or raw data. And if I'm talking too fast, just interrupt me. I don't think this is very important. I'm going to present a very nice demo afterwards, actually, which demonstrates how you can build such stacks, and this should be the focus. But I'm trying now to just explain the context of this talk and this type of system. But the idea behind data lake is that you should be able to retain and collect all your raw data in its original format. Don't bother converting it into some nice or shape format. No, just take it as it is and store it as fast as you can. Put a format later on, and this is really in contrast to the existing data warehouse systems nowadays. Put and enforce some sort of structure later on once you have a particular use case and you know how you want to use this data. It makes no sense to try to shape the data very early in the process into some generic format, presuming that you'll be able to serve various use cases, because at the end of the day you cannot serve better, nicer, to full efficiency either of those use cases. So, but this is one of the examples. Lambda architecture, I'm not sure. How many of you have used Hadoop or big data system? Or okay, so I'll go a little bit. So Lambda is a very popular, again, architectural patterns common within this space, which tries to get the best of both worlds of transactional systems, like Mifos, and analytical data processing engines, and provide unified view on top of this. On top of them.
You want to what?
Yeah. And it's very related with the demo stack I'm going to show later on. Lambda is another version of this, actually another architectural pattern that does the same, tries to answer the same question, but from different way. It uses distributed transactional walk, again, technical decision. Vacuum is another way that of doing and achieving this type of processing, data processing. It actually creates a memory data layer on top of existing data systems and benefits from the various principles that, like the immutable data, fact data, determinism to achieve the various factors. So, okay. I really rushed these first parts. I don't think it's very important. It was okay, just to give you some insight about what are the driving force and what are the efforts and the different architectural patterns and principles that goes behind. So I'll try to ground now the rest of the presentation with more real and touchable demos and give you some insight how we can build such type of system experiment. So this is the main goal of this presentation, to show how actually can grab and connect those different applications out there and simplify the operational and functional cost of those systems while still benefiting from the system that we are integrating, particularly data processing system. I'm going to use in-memory data grid, which is the example of a transactional system. You can think of this like Cassandra that's been used is planned to be used in the next release of. And you can use Hawk is SQL on Hadoop analytical data engine. So practically you can process terabytes of data, so practically your 10 years period of collected data and stuff, so it's just the opposite. You can have those two systems, and in the middle you can actually, ADFS stands for Hadoop Data Distributed File System. So this is the idea that you can store data within your data lake. This is the architectural principle I mentioned earlier, that you can actually keep your data in its raw format and then reprocess this case particularly, we're going to have a correct real-to-it data from based on some criteria, store it in parallel into your data lake, have the same data from the data and put it within your memory data processing system and in your analytical data processing system, and would allow you to extract and operate with these different systems at the same time. So, as you can see, in order to do this kind of things, I've assembled actually technical stack which put together various open source projects and platforms and provides unified view on top of it. So again, the point is that you can combine these things together and create a nicely and nice end product which actually allows you to cut on operation cost and on development complexity, which is usually the price that you pay when you integrate different types of systems. So this is the opposite. Ambari, have you heard of Ambari? It's Apache Ambari, so it's an open source project which is used for operational provisioning and monitoring of various services. It's pretty easy to get any system, wrap it as a service within Ambari and actually benefit from the script. But again, this is just ideas I'm throwing around. It's and you can use Apache Ambari as your operational tool to operationalize various services on behalf and provide a singular management and provisioning layer and tool to talk with. I was preparing to go more in details about how we can actually do this in practice and implement it and what are the benefits in doing this stuff, but I rather prefer to stop here and see some feedback or just let me know what you'd be interested. I presume that would be, and personally I would really want to see how, or maybe whether you see some interaction and how you see overlaps and how we can connect the dots and make use of both worlds and financial. So, yep.
What if I have Unicode data that is non-Latin characters, as in umlauts, or other languages?
For this particular use case?
Japanese. We are using this stack.
Okay, so from the ingestion standpoint, we've used a tool called Spring XD, and there you can actually configure the encoding the way you prefer. So that's
the encoding.
Yeah. So.
Okay.
And from the Apache Zeppelin stack, this is actually your web front end. That again, it's just a web application. Depends on the data that you spit out. You can actually always encode it on the way. So you can implement your own interpreters. That's how Zeppelin works. That covers any application on behalf and depends on the implementation of those interpreters or this kind of plugins. You can have various support for various encodings. So this won't be a problem. If you have a particular use case that you would like to plug into this type of stack, I would love to help you on this stuff. So I'm pretty sure that encoding will be the last issue we have there.
Most of these modern libraries are full Unicode enabled.
Yeah.
So you can configure them as to which flavors of Unicode you want to use.
So the software delivery. So I'm picturing the vision that Marcus just showed us with the commands and the events, saving the commands, saving the events, adjusting the database on what's come in.
So Marcus talked, and that was interesting, so by the domain-driven application, and he mentioned two patterns that are very common. This is the common query segregation, data segregation, which practically means that you should have two, I'm not sure if you're familiar with this pattern, but practically the essence of it is that you have two different ways to process and to manage the command, which is practically action that actually writes into your database or actually does some actuate, and the way how you actually extract the data. So this is, you have two segregation. You're able, this pattern allows you actually to deal with these two different word patterns in different ways, because very often they actually have very different nature for tuning and processing. So this is what is the essence behind this pattern. So it's pretty basic, I would say, and within the context of Mifos, it has it's a typical transactional system. So there, this is the one of the way you optimize it, and it's not really related with the analytical stack itself. The second part, actually, what you mentioned is more interesting, is event sourcing. If you remember, the event sourcing practically means that all your transactions, that's very interesting stuff, and it's very essential for many systems out there. It's actually the ability to record any transaction, any action within your system. Practically to make it atomic and repeatable and recorded sequential with time, so very well step, which means that at any moment of time you actually can replay this sequence of actions, and this is what is this event source supposed to do. Within the context of this technical stack, the typical use case we're going to use so this tool is actually a typical example for high-scaled event sourcing distributed system out there. So it's a distributed transactional log. And as you can see, it's yet another Apache project. It's being used and built by Twitter. It's a very capable system that you can use directly, or you can use as a part of our Spring XD integration. So this is interesting way. So again, as I see the Spring XD as a tool, is kind of superset of integration. Any of the system you use out there has already some capabilities for ETL, for some sort of orchestrations, but it's usually limited within the boundary of these systems. While at the end of the day, you need the one super system or meta system that is able to put all those components together. And Spring XD is one of those systems available out there. Actually, one of the best systems that you can use out there. And I think hopefully the demo I did visualize how actually put different components that knows nothing about Spring XD. They're very different in nature. In the end, you can have more unified view on and processing of data across those systems. So using this feature, you actually can benefit both Spring XD and Kafka as your underlying event source engine. That's what Marcus is going off. But maybe I misunderstood the question.
Well, I'm trying to figure out how you deployment because what you've shown us is I input this command here, I input this command there. I'm guessing there's a way to put it together that you put it on the GUI and you can actually hand off to a client and say, run this, call this command, and it'll work.
Yes, of course you can build all these kind of things. All those commands works based on some APIs underneath. So I deliberately wanted to illustrate how you actually explore and get more interactive processing with your backend systems.
Yeah.
Because that's the way. But within the context of product, of course, you're going to wrap all those things. All the backend system provides some APIs. Most of them is RESTful-based APIs, particularly within this data stack. So actually, you can automate the interaction with the systems. And furthermore, with Ambari, this is the operational tool. You can actually bundle the whole deployment stack as well, and there's something called blueprints, or a way to actually bring all those components as a singular or well-defined installation entities, for which you can automate the whole installation process if that's necessary. So this is, again, I'm not sure whether you and how actually the operationalization and bundling of the product is happening right now, but Ambari could be a very good candidate to bring the various services together and have a singular installation process that does this for you. But
so next, if I can ask another question.
no, please. As I said, I'm trying to connect the dots. So the more questions, the better.
I'm imagining replication is built in, but how would you how would you say, okay, this what do you call it? This channel isn't keeping up. How do I duplicate it? I need to replicate that and get it going.
It is within the communication between different modules. For example, this pipeline I've shown, it had this kind of source, some data gets in, it gets processed, gets passed to the next processor, and finally ends up within a sink or some final system. Is this the?
Yeah, so if you've got a step that's going slower than the other one, so you might want to
Okay, so I haven't mentioned this, but for example, within Spring XD, the whole communication between these components, for example, source, processor, next processor, sync, happens through some sort of event bus underneath. Out of the box, I mean, you can use either local bus, so everything happens in memory if you don't have a distributed system, so partly you use simple thread pools and queuing within memory. This is not a reliable way, but the production version actually supports RabbitMQ, zero message bus, or Kafka. Again, the same distributed event reduction tool that I mentioned earlier. So Kafka, and usually using those event buses, you can guarantee they provide various enterprise features that you can partition your input based on certain criteria in order to decrease the load. With Kafka, you can actually store or persist actually all communication that goes between these components that you talk, or you can with this Spring XD also you can do something. You saw that the tapping, so partly the forking underneath, is implemented by the bus that underlies Spring XD. It could be RabbitMQ or Kafka, and usually those are event buses that allows you to have a different type of topologies to Spring and to stream data. You can have a topics, you can have a peer-to-peer type of communication, but actually it's translated to communication and replication at that level. Furthermore, Spring XD allows you, it's based on a library called Spring Integration, which internally actually intrinsically has capabilities to repeat and to actually have acknowledgement for. So it won't actually continue the process if it hasn't received the acknowledgement that the data has been moved to the next component reliably. If it fails, depends on the nature of the failures, it can try to repeat it a couple of times. So there are different strategies where it can actually log the output to the process to some error failure queue, so that later on you can, the operational guy can take look at it and see how it can actually recover from this situation. But there's various mechanisms you can actually do it in order to.
Spring XD will also allow you to route to a pool of nodes. So you can. Spring XD makes it easy to flow messages to what looks like at one level, one node is actually a pool of nodes. So it makes it very easy to replicate. If you need more capacity at a certain point, to easily increase the capacity without having to redraw your old map and reroute things like that. And then if you really are into that kind of stuff, there's a whole movement of people called reactive programming, which is not yet implemented in Spring, but
partially
will be down the road, which is a protocol whereby nodes can actually signal to each other if they're getting overloaded. So if one node downstream is getting overloaded, it can signal up to the guy, hold on, slow down, I need to catch up.
Yeah, it is really push back the back pressure actually, so that actually the whole entire your source data producer actually gets a and master. So this is you can see, you can monitor and see various aspects of it. We're going to check now the Zeppelin. This was the analytical platform that's running on top of it, and this is actually how it looks. As I mentioned, it's a web-based notebook system. The concept is that you have this notebook which has multiple paragraphs. So this is a single paragraph, and each paragraph can start with some sort. So this is some sort of prefix explaining what would be the backend system is going to talk with. In this case, it's the Markup language. It supports this, and practically this output here is the result of executing this script. So this is just to show some text. Next thing is we're going to build the first pipeline I mentioned, is the Twitter. This is actually in real time going now to query some data from Twitter based on some keywords. In this case, I used WordHash. It's pretty neutral. Hopefully, the content that we get going to receive back is not going to be offensive anyhow. I've been having a problem with this to find something that is stuff. But again, we have the Twitter search source. We're going to query it by word, and the output is going to be stored in our Hadoop PageGFS file system at this location. Okay, I'm going to start this pipeline, and I'm using the Zeppelin. Okay, and here, as I mentioned, Zeppelin, I'm telling Zeppelin that I'm going to use my Spring XD stream backend system. So practically it talks with our Spring XD. So Zeppelin talks now with this system on behalf, and in order to execute this stream, we can see what is the content of, because we said that we want our raw tweets to be stored into this location. We can actually check on HDFS file system whether some files have been collected. Okay, yeah. So more and more, this is how the HDFS looks. I mean, logically, it has the file of single tweets, but internally it breaks it in multiple chunks and stuff. So this is not very important for you. It's just important to realize that we have implemented the first step. We're practically at real time now collecting tweets and storing in our file system as they come. Yeah, you can actually take a look, for example, cut into a single tweet, hopefully, as it comes from the file system. Yeah, so just to make sure that you see it's in the JSON messages that are stored here, and if we list again this folder, I would assume that the number of tweets will accumulate more and more, simply because we have told here there's different parameters that we would like to roll over the size of the tweets into a 10 case, so it practically breaks up multiple small files, but also features of the HDFS, and how you handle large amount of data on Hadoop-like systems, so it has particular architecture and decision there. We can talk about this offline, but I don't want to borrow it, there's particular reasons why those are done like this. What is important for the purpose of this demo is that we now can actually have a running pipeline, and we can use the Spring XD actually to visualize the. Okay, so we have the source with search, and it loads the data within HDFS, and this is real-time shows you the throughput, how data flows. This is the Spring XD tool, that management tool that allows you to do this. Next step is to actually direct the same flow to our in-memory data grid system. So using the second pipeline, it's here, we're tapping the original tweet stream that we created before, and we're directing the same data to our job server, our in-memory data grid. I'm going to create this, and the output is stored into a region. So this is the Gemfire's abstraction for data store. You can think of this like a table. So the Gemfire is called, or Geode is called region. So we're going to store the incoming tweets into a region called region tweets. And here's how we're creating the region here. This is like this. This is not very interesting. Now, once the data starts flowing within our Geode stream, we can actually verify this again. We see now that from the Spring XD console, we already have a second stream that taps the first one and loads the data in our in-memory data grid. And we can start using queries on the Geode, practically Geode. Allows us to have SQL-like interface. In this case, we're going to query directly, so the tweets about the create tags, username text, and stuff like this. Hello, Paul. Hi. Welcome. Having built this this second part, okay, we can, for example, check the amount of tweets that we receive. Another similar queries. So, and this number grows progressively. So, what we did is we built this secondary pipeline that with Spring XD that actually folds the main tweets stored in HDFS and puts them in memory in our data grid store. And we also were able to perform it's called object query language queries against this data store and see the content of this store. And all these things happen in real time. So this is our transactional system. Now we can try to do similar type of exercise, but forking the mainstream that actually lands data into HDFS or data lake and put it into our SQL Hadoop system, so our analytical data store. For this, we're going to do one additional step or one processor that is going to convert our hierarchical JSON messages into tab-separated lines, which are suitable to insert in our database. And this is how. Do you see, by the way, the so? Again, it's very similar like the previous, the geot tab. We're going to geot stream definition. We're going to tab the original stream to it, and the output is going to be transformed by a script, which I'm going to explain later. And the output of this script, which is this script practically converts the JSON messages into tab lines, extracting the interesting values, and the output is stored in our Hadoop data system using this out-of-the-box sync that SpringXD provides into a table, XD table, which we have defined here earlier. Just some selected fields from our tweets are going to be extracted and used. So once again, our stream forks the main tweet streams and transform the JSON into tab-separated values. This is the script. It's longer, but what it does, this is the conversion script. It practically on the fly converts the JSON message, the text into JSON object, and this is a Groovy script, and extracts certain fields like the created date, language, tweets, actually all fields that we're interested to put within the table. And the output is tab-separated lines. So this is what would happen here. So we are building up, this would be our third stream. As you can see from our SpringXD console, again we're tapping forking the main stream to it and transforming it and landing the data in our SQL Hadoop engine. We can actually verify whether the data has ended in the right place, practically we're now using the SQL from our, again, Apache settling front end. We are telling this front end that we want to talk with our SQL engine on behalf and performing some SQL query to see what is the content. And again, data start to flow in, and you can actually explore what is it. But to just visualize yet and to demonstrate another aspect of this integration stack is that now we can do some interesting analytical queries like how you group how the tweets are grouped by language. So if you can read this, it's, not surprisingly the English is dominant, but you can start using some Apache settling features that would allow you to explore and give you some preliminary insights within the data. And just as a last example, this is a feature built in SpringXD. It would allow you to actually SpringXD comes with some built-in analytics capabilities, and in this particular case, it would be the ability to count the number of incoming tweets. So this is yet another. It practically taps the inputs and uses the pre-built out-of-the-box counters component, which you can visualize, and practically this would real-time show you some insight, provide you some insight about, in this case, the number of incoming tweets that you have processed. Back to the technical stack. Again, I think you have maybe already some insights about the idea that what I wanted to convey is that you can leverage various open source tools out there, like Ambari to cut on operational costs, or like Cloud Foundry, which would actually gives you yet another operational angle on combining the integrated code system. But I believe Paul would actually touch upon this aspect tomorrow. And for example, using Apache settling to unify and provide you to a single or unified analytical view across various components that you can bring within the package. And this is an example stack. I think it's flexible enough that you can build it in way. For example, I'm pretty sure you can integrate your components within Apache settling as well. and use the setting as kind of your singular web-based view in order to talk and extract and run some queries if that's necessary. The fact that your end source and things are actually struggling to cope with this data, so direct programming actually allows you, and even the thing that we use to load the data within our Hadoop SQL Hadoop system already implements internal implementation is rapid implementation.
What you're seeing here is these techniques are being used by people who are building very, very large scale systems. You know, things that are handling literally hundreds of thousands of events per second. In our case, in Mifos' case, we're unlikely to be handling those levels, rate of events anytime soon, but we may be one day, which is why it's good to be thinking about all of this now, making sure that we're taking best advantage of the programming patterns that are emerging in the cloud-based world. And the great thing is that there are all these libraries now that various people are making available that make it easy to write applications that are more scalable and more resilient than anything we've seen before.
Christian?
This just to finish, so I think this is kind of related. This is the view from the Spring XD management console. Within this particular setup, we have 5 separate nodes that handles our Spring XD loads and pipelines. And each of these lines actually represents this node is a separate. We can check it, separate IP. And you can see that the various components within our pipelines are evenly distributed across the various systems. For example, the Twitter searches and plus the transformer perform in one node, and you have all this. This actually even showing in real time how the throughput goes amongst them. But as you very easily can actually add more nodes and more Spring XD containers. It's the terminology of this particular runtime setup, and the load and the actual processing nodes will evenly be spread and load balanced across these components. And the message bus that underlies it's configured to this Spring XD will take care to establish the communication in a reliable and scalable way among the modules below. The beauty is that as an application developer or high level, you don't have to care about this. You really can scale out your system, and you will still have the same single DSL string that represents your pipeline and stuff. So you don't have to take care about how this exactly is distributed or scaled underneath, or how the data gets forward or sync itself.
What if I have a country where the government does not want anything to run on a cloud, and I have to run it on a single server? So probably, for example, right now, so we are a Mifos partner, and I'm the founder, and I'm a technical entrepreneur. And we are playing with OpenStack right now as something for the future where, so how compatible is this with OpenStack, for example?
This is really more around application development, but if you want to talk about the OpenStack and how you actually want to have a on-premise setup, then Cloud Foundry is my natural answer about this, and I'm pretty sure that...
Well, the simple answer is any system that will basically serve up and manage Linux containers will do the job.
Okay.
So you can layer this stuff on top of anything that's a container management layer, basically.
In this case, practically this particular demo runs on a virtualized vSphere system that we have. So I mean, it's in-house and stuff. I can run it. I have a script that actually allows me to build it on top of with Vagrant within a single node as well. So practically you can do it by yourself and stuff. And again, I misunderstood your question, but yeah, you don't have to. You can actually build on your single laptop. 16 gigs is enough to have most of this.
So to connect the dots a little bit back to Mifos and the data requirements we see. So I think because Mifos is really traditional transactional, especially in the current version, what you see is that when you start running reports, you also quite quickly start running quite traditional SQL queries against that same transactional database, and you quite quickly start setting up read replicas because hey, it's not very nice to be writing queries against your. So what we see with the clients we're currently working with is there's just people want to do more with BI, people want to do more with the data they gather, but it's getting quite tricky within the current data model. So I do see a lot of value in, for instance, Hadoop. But when do you decide to push data to Hadoop, and when do you also then decide to start pushing data into Hadoop? Because we currently only have one data source, right?
You have your main transactional data source,
Right.
which is the MySQL database, and as I heard, there is already some troubles, and from performance standpoint, not because of the report, but in general, there is some drive to try to generalize this and kind of abstract from this stuff. But I don't see the problem that, and this is again aligned the data lake paradigm, that you can actually store most of your data again in parallel to landing the data within MySQL. So of course, you can have different paradigms. Very often, this traditional enterprise data warehouse would, if you want to migrate within Hadoop space, what usually we're going to do is going to put the data lake or this Hadoop system in front of your ingestions. And for example, combination Spring XD and Hadoop HDFS, you can actually use this as a kind of unified store for the incoming data, and then put the existing warehousing system or the existing databases afterwards, and feed those systems with some subset of the data lake data. So we have this not ETL but EOT type of processing that actually extracts some subset of data and loads the system. So for the end system, the transition is almost seamless, and this is very good things to start with with this kind of integration. So something similar maybe can happen here. I'm not sure what is the type of reports, but it's really subject specific. If you want, and I assume that some of the data that is being queried is actually produced by the transactional system itself.
Sure. Almost all of it. So that was mainly my. So we currently most of the people using Mifos have that as their single system, their single version. We're not using microservices. We're not putting together a lot of libraries yet. We're not storing. Well, we want to start storing the commands separately and then process them.
Okay, so there is a I think this is
This is a question we should reserve and ask to Marcus.
Yeah, and I can suggest some. I can suggest some easy solutions for this, but this won't be the.
It's mainly we've been sparring with Marcus about it as well, because there's just one of the things that we see just a lot when you start querying the current database is that the data model doesn't really allow for any decent reporting. If I want to now. If I want to plot a graph of the organization's portfolio at risk over the past 6 months, then for some of the larger MFIs, even on pretty hefty SQL instances with Amazon, that's going to take you like a couple of minutes.
That's why I think you should get Marcus in the room and palm wrestle with him rather than
What I wanted to say that the tools that we discussed so far actually provide you out of the box solution for this. For example, within the Spring XD space and Hadoop, you have something which is called Scoop. I don't see it here, but it's a processor that actually allows you to extract data in batch from a relational database and load it within Hadoop.
Yeah, and I think
so you can do actually this kind of scheduled batch, and Spring XD is a pretty trivial to build a pipeline that actually does this in some regular basis. Here's Marcus. So we've been discussing that. Okay, shall I repeat the question? Because it's an interesting question. Or shall we go? Is it time for dinner already?
No, we delayed that till 7. What? Except for the German.
They're accusing you of slowing their systems down.
So Marcus, we were just in we've been speaking about this before. Essentially, you have Hadoop, you have the essentially the whole capabilities, and you have the current data model. And essentially, how to start going from the current data model into a more flexible data store that allows you. Let's say I want to plot a graph with my PAR for the past 6 months. Kind of stuff, and what your thoughts are in line with the Mifos.io plans of if you've already put some thought into how we would want to approach that, and whether you want to start aggregating straight away or whatever.
Good question.
So now we're putting him on the spot. Sorry.
So first of all, one of the things I think we maybe done not that nicely is that we didn't really start aggregating data today. That's something that we simply needed to do, but we never done.
I know it's not nice, but it would be much nicer for the rest of us if we come to the front.
Okay.
Yeah, so yeah, we obviously do aggregate like current status, but we don't do any like over time status. We have the current status of any loan aggregated, but anytime you want to go back in time, yeah, you need to recalculate.
Okay. So you saw my slide in the morning, right, where I already have the group there.
And then a big to-do remark.
Right, then the big to-do remark. So I have it in my mind that we need that. But it won't maybe be in the first shot because I need to simply piece it down to workloads I can handle or we can handle as a team. But Hadoop specifically is something that I already have in mind. And also will keep in mind that we'll have it in there. Just simply to spin up data and do something else with it. But I need to.
The group is just one example of what
Right.
you could be using there. I mean, the reality is, if you're highly SQL oriented, it'd probably be a lot easier just to use one of the columnist SQL stores that are out there. If you're talking Anson land, to use Redshift rather than Hadoop. But there are other such capabilities out there. So you really just need the capability to move it into whatever is your analytics analytics optimized store in that environment.
Yeah, I think ultimately it's all about deciding when you start aggregating and how you start aggregating, and if you do that at source or.
So Ali already mentioned that too, right? So we will have a NoSQL store already, which is a key value store. It's not really a column store, but it's at least a key value store. And he said, why not simply also pushing data while we're handling the events, also start pushing data in that event store for caching it. Right? And that's what we talked about, and I said, yeah, that's the big vision at the end. That's exactly what we talked about. So right now I need to tackle, first of all, the scalability.
Oh yeah, but it's not putting you on the spot or anything like that. It's more about, well, we're here with somebody who has a lot more experience with Hadoop than I think you and me would have.
Yes.
So it's better to pick his brain than
Yeah, but I would love to continue these discussions when we have more focused view on this stuff. What is clear, no matter what is the backend for analytical stuff, most likely it will be a different system from the transactional.
Yeah.
So one hand we were already tackling the transactional aspect as well. I think you mentioned Cassandra and stuff. So but most likely there will be the interesting bit is at what point we're going to keep and aggregate the data within these both systems.
In the former company, what I've done is I've introduced Actuate, which simply is a column store to do exactly BI stuff. Right? And I had a hard time fitting it into the current system. Right? Because the system was simply designed not really to be that open. And with this experience, is how I'm currently designing my architecture. So I want to have a column storage in there because it's simply the best thing to do when you start aggregating data. But I can do it right now. So that's simply, I keep my design open on that end so that I can use it. And maybe I won't use Actuate because it's priority, right? We use Redis or something. And but at the end of the day, there is a column storage